Let's move on to another much bigger CSV file. This is the species file. It contains information about all the species at the different national parks. So each species has an ID and it's connected to the park by the park name. Then there's a category, there are mammals, there are birds, and so on. Species have a scientific name and a common name, and there's a conservation status associated with some of the species. These are the questions we need to answer about the species file. How many total species are there? We'll be counting species IDs here. How many unique species by scientific name are there? How many endangered species are there? How many native species are threatened? How many bird species are species of concern? What fish species by common name are threatened in Yosemite? And finally, where can we find bears? So just like we did for our parks file, we need to read the data into a pandas data frame. So we do that by calling the readCSV function. We pass species.csv, the file name, as an argument. In this case, we want to use the first column, the species ID, as our index. So we specify index column equals 0. We're also only interested in the first 13 columns, so we specify use columns equals range of 13. And that should load just what we need. This will not load any extra columns that we're not interested in. The first question that we need to answer here is how many total species are there? And we'll just count the number of species IDs. Remember, the species IDs were used as our index, and the species IDs were unique. Each row has its own unique species ID. So to answer this question, we just need to return the length of our data frame. That will give us the total number of species IDs. For question number 2, we need to answer how many unique species there are, and we'll define a unique species based on the scientific name. So our hint here is to use the unique method. The unique method allows us to remove duplicates from a series. So when we invoke unique on a pandas series, the return value will be a NumPy array. So let's see how to use unique here. We're going to get the series corresponding to the scientific name. df of scientific name is the whole column in our data frame. Remember, columns in a data frame are pandas series, so we invoke the unique method on this pandas series, and we get a NumPy array, and the length of this NumPy array will give us the number of unique scientific names in our data frame. So this is how we would answer this question. For question 3, we need to figure out how many endangered species there are. We need to create a Boolean mask here. So the Boolean mask is df of conservation status equals endangered. That's going to be our Boolean mask. We're going to index the data frame by this Boolean mask. And this is how we do that. We just use the Boolean mask to index, using lock, our data frame. For question 4, we need to figure out how many native species are threatened. So here we need 2 Boolean masks. We need a Boolean mask that filters by threatened species, and we need another Boolean mask that will filter by native species. So we can use the bitwise operators and, or, and not to combine Boolean masks. So this ampersand sign here is an and I can use it to combine 2 Boolean masks. Now, it's important to enclose each Boolean mask within parentheses when we are combining them with and or. Remember, these are Boolean, they represent Boolean values, so we can apply bitwise operators to them. So this will give me a data frame that contains only those species that are threatened and that are native. And if I get the length of this data frame, I have the number of native species that are threatened. Question 5 is very similar to question 4. So please stop the video and try to implement it on your own. Okay, so in this question, we're asked how many bird species are species of concern. So we also have two Boolean masks here, one to find bird species and the other one to find species of concern. So we do what we did in question 4, we apply two Boolean masks and we join them with AND. So this gives us a data frame that contains only those species that are species of concern and where the category is a bird. So this gives us the right answer. In question 6, we are asked what fish species are threatened in Yosemite. So we are supposed to return not a number, not a value, we are supposed to return a panda series that contains the species IDs and common names of fish species that are threatened in Yosemite. So we're going to need Boolean masks, just like in the previous question. And we have three conditions here. We have to filter on fish, we have to filter on Yosemite, and we have to filter on threatened. So all these three conditions are going to be part of our Boolean mask. And instead of returning a length, we need to return the series, and we need to project on the common names column. We don't need the whole data frame. We just need the common names of these species. So let's see how to implement this. So we have our three masks. Conservation status is threatened. Category is fish. And park name is Yosemite National Park. We project on common names. We don't want the whole data frame. We only want the common names. So we add the common names in our lock index. Remember, when we're looking for a value by row and by column, we can index by the row first and then add a comma and specify the column. So this is what we're doing here. But instead of specifying a single label, we are specifying a mask here, a Boolean mask, to select the row. So this here takes care of the row selection, and here we take care of the column selection. And this is the result we get. So we get a panda series here, and these are the two fish species that are found in Yosemite and that are threatened. So we have the cutthroat trout and the rainbow trout. And finally, for our last question, we're looking for bears. Where can we find them? So here we need to return a NumPy array containing the names of parks with bears. So how do we get all the bears? We could use a Boolean mask to find a bear, but the issue is that bears come in different flavors. Under common names, we have American black bear, we have brown bear, we have black bear. So we can't put just a single mask for bear and find all our bears. The other issue is there are some common names that contain the word bear in them, like the bulb-bearing water hemlock. And the bulb-bearing water hemlock is in no way a bear. So how do we go about this? We can't exactly use the Boolean mask like we did before, but we can use string contains with a regex. So here we need to use string contains, and we do that. We specify the regular expression bear on word boundaries so that we pick up only real bears, and we ignore the case. And we want the common names column to contain this regular expression. We also need to add a category because it turns out that there's a black-anded bear that is no bear either. That's a poor little insect. So we want to exclude it from our result. So we add a category equals mammal. So now we have to filter by this as well. So this is our Boolean mask. We have two of them now so far. We have the common names that contain bear and the category that's a mammal. So now we are making sure we're getting real bears only, but we are only interested in the park name. So we have to project on the column park name to get what we need. And here's what we get. We get all the species ID in all the parks, and these parks contain bears. Now notice here that I have Carlsbad Caverns National Park that appears twice here. That is annoying. So let's see how we get rid of duplicates here in the result. We can do that by calling unique on the result, right? So we have seen unique before. We can call it on this series and we'll get a NumPy array. So this is our result now, a NumPy array of all the parks that contain bears.